All right. All right, we're in 7.3. I'm going to kind of do things backwards at this point. I'm going to go 7.3, 7.2, 7.1. It's a little easier that way, to do it that way. So you'll notice that's in the homework as well. It's in that order. All right, 7.3, the elimination method. All right, how do we do it? We need to, here, let me bring them over here, make them a little bigger. We're going to take these two equations and we're going to add them up. This method is called elimination. It's also called the addition method. So the addition method or the elimination method, it goes by either name, aka also known as either one. So if we add them up and we add straight vertically, so x plus x, adding straight up and down, what will that be? 2x, good, because it's just 1x and 1x, huh? Yeah, and then when you do the y's straight up and down, I'm just adding straight up and down. Yeah, they totally cancel to be 0, or you can just put nothing. Same thing either way. Equals, and then straight up and down here, negative 7 plus 9, 2. So that's just 2x is 2. See how y has dropped out, by the way, before I go on? Everybody see how y has dropped out? Which is nice. Why? We like that because we don't want 2 letters. We would prefer to just have 1 letter. So we just have x. What do we do to finish? Divide by the 2. X is 1. So we got an answer for x. Now, can we get y? We need y also because that's part of the original question. Now that we have x, we have half the answer. How do we go get y? What do you think?
Plug 1 in for x.
Yeah. So plug in the x equals 1. Plug in where? Pretty much anywhere you want. Like I'll just grab that first equation and I'll just use it. So that's what? X plus y is minus 7. Put in that 1. 1 plus y is minus 7. Solve for y. How do I solve for y? Subtract the 1 from both sides. Y equals negative 8. So then the overall answer to this question is 1 comma. They want the x and the y with the comma and the parentheses. 1, negative 8. See how they say type an ordered pair? So that's what they want there. 1, negative 8. Is that good? Questions on that one? Yeah, you could go either way. We good there?
No.
Good. Well, if you there we go. Try that one. Same kind of thing. Just add those, right? Just add them vertically. So add those straight up and down. So x and 4x, so add straight up and down. X and 4x. 5x. All right, and how about plus y and minus y? What's that going to do? Just going to drop out, cancel, right? 14 and 16. 30. We good there? All right, what do we do? Now we have just x, which is nice. What do we do? Divide by the 5. So x is 6. So we got half the answer. We got x. How do we get y now? Yeah, so bring it up. Plug in x is 6. And where do we plug in the x is 6? Yeah, for x in any equation you want. Do you realize that? You can plug into the first equation, the second equation, any equation. I'll just grab the first one. I usually just grab the first one. So x plus y is 14. Put in the 6. 6 plus y is 14. Subtract 6. Y is 8. Like that. So the answer is 6, comma 8. It's always x. It always goes alphabetical, right? X first, then y. 6, comma 8. Is that good? Questions on that one? Hey, how could we check? Suppose this is the exam, right? These will be on the next exam, exam number 3 in a couple weeks. How could you check to make sure it's really right?
Take the second equation, 4x minus y equals 16, and then plug in your values for x and y.
Yeah, both equations.
It should equal 16.
That's right. So if I go back to me and I put 6 in for x and 8 in for y, in both equations, 6 in for x, 8 in for y, it should make both of them true. That's what it means to be the answer. Is it right? Let's see. 6 plus 8, is that 14? Sure. Now the other one is 4 times x, so that'd be what? 4, let me squeeze it in. 4 times 6 minus 8, so that's what? 24 minus 8. Oh yeah, 16. That's right. See how it's working? See how x equals 6, y equals 8, make both equations true? That's what the answer is. So you can check, right? That's why these will not be on the multiple choice part of exam number 5. These will be the very ones. These will be the very ones that I do not put multiple choice on, just like on this last, because you can just plug them in, right? I can't give away the farm like that. You can just plug. You can just look at the options and just plug them and grab the right one, right? So I've got to leave these open-ended. It'll be just like that. I'll give you this question. So you got to practice these until the point where you can do them straight, not just with multiple choice options staring at you. Right? These will be that. And you'll see that on the practice exam. Good on that? Let's keep moving. All right, so go ahead and try this one here. I'll rewrite it over here. X plus y is negative 9. 4x plus y is negative 3. Go ahead and just add them up. Do what we've been doing. It won't work this time, but go ahead and try that. There's something important that I want you to see there. If you add them up,
The y's don't cancel out.
yeah, this is 5x. Whoops, I'm kind of scribbling a little bit. This is 5x, right? Because 1x and 4x. What happens this time with the y's? Yeah, they do not cancel, do they?
No.
Because on the last couple of problems, I had a positive y and a negative y, and they became 0. But not this time. This time it's plus 1y is plus 2y. And I don't know what that is, minus 42. Thank you. Anyway, my point is, that's no stinking good. I'm going to back up and start over. Why not? Why is that no good? Because y did not cancel. Y did not cancel. Well, so what? Why am I so obsessed with y canceling? Because I can't solve 2 letters at the same time. You see the problem? I can't do 2 letters at the same time. I need somebody to go away. I need somebody to drop out. Does that make sense on that? So, how do I get somebody to drop out? I got to go back to the drawing board. And why did they? Let's look back. Why did they drop out? Say on this last. What made the y's drop out back here?
Subtracting.
1 positive, 1 negative, huh? So I've got to make the y's that way before I add them. If they're not already that way, which they never will be again. Those first 2 were just nice little warm-ups. They're never going to be that way again. You're going to have to make them that way yourself before you add them. So I got to go back and say, all right, no, this isn't going to work. Let me erase this. Let me go back. I got to make them that way. So here, let's erase the whole thing. So what you have to do is you have to, let me rate it again. X plus y is negative 9, and 4x plus y is negative 33. Yeah, so I've got to make one of those y's a negative y. It doesn't matter which one. I'll just do the top one. So if I'm going to do the top one, you got to multiply through by negative 1 the whole equation. Does that make sense? We can't just change the y part or something like that. We have to do the whole equation, don't we, right? It's an equation, left side, right side. Whatever you do to one side, do the other. Keep the balance, keep the equality. So we get negative x minus y is plus 9. And then the second equation, I'll just bring that down, no changes. Now I'll add them. Now it'll work. Does everybody see what I did there? I multiplied through the top equation by -1. Just the top one, yeah.
Yes, ma'am.
Just the top one. See why I know that's going to work? See how the y's are opposites now? A negative y and a positive y? Everybody see that? So now it'll work. So 4x minus x, 3x. Y and negative y, cancel. 9 minus 33, what is that? Minus 20. So what is thanks? Minus 24. Is that good to there so far? See how the y's dropped out? That's what I wanted to happen. The y's drop out, right? Because I got to get down to one letter. I can't do two letters at the same time. So now, what do we do with 3x is minus 24? Yeah, divide by the 3. So x is minus 8. We good? Now we're halfway there. Really more than halfway, huh? Now you just finish the same. Just plug in x is negative 8. Where do you plug it in? Really, literally anywhere you want. Any of those four equations will work. Just plug it in anywhere you want. They're all good. I'll just grab the first one's what I usually do. Just grab the first one and say, okay, x plus y is minus 9. Plug that in. Minus 8 plus y is minus 9. Add 8. Y is minus 1. So the answer is negative 8, negative 1, xy. There we go. Yeah.
Question. Okay, so you go back to the original problem and you don't use the converted?
You could do either one. Yeah, you could go back to the original, that's what I always do, but you could use one of these converted ones if you want. They'll all work the same, they'll all give you the exact same y value.
So
For
you
the,
have
on
to
the
use
plug, we're
the
talking about
9?
the plug-in step, right?
Yeah.
Yeah,
So you
any
have
of
to
them.
use the negative or the negative 9 or above the 9? Or can you use the 33?
Yeah, either one.
And it'll still come up with the same answer?
It really will.
Okay.
Yeah. You can use any of them. Yeah, so when you do the plug-in step, just grab anything you want over there and do the plug-in. It'll all come out the same. We good on that? No other questions?
By habit, you just use the first one.
Exactly. It's just simply by habit, but not required. That's right. All right. So, all right. So there we go. 8x minus y is 22. X plus 3y is 9. So, I want to make, look at those y's. Are we ready to add the y's right now? Are they opposites right now?
Yeah.
Well, they're opposite signs, but they got to be the very same number also. If I add them right now, don't write this down, it won't work. If I was to add them right now, it's not going to work. I'd get 9x, right? 8x and 1x. And this is really minus 1y. And 3 would be plus 2y. See, the y's would not cancel, would they? See, I've got to make this guy a minus 3y, don't I? So he adds to the plus 3y to be 0, and the y's cancel. Do you see what I need to do? I'm going to go back. I've got to, before I add them, this didn't work. Don't do this. Before I add them, I got to make this a minus 3y. You see the name of the game? You got to make the two y's be opposites before you add, so that when you do add, they'll be 0. They'll drop out. You've got to make the y's be opposites. Same number, one positive, one negative. Make sense? That's what you have to do. You have to multiply to make that happen. So let me go back, say, okay, that didn't work. I'm going to make that top one. So what am I going to do with the top equation? What am I going to multiply the top equation by?
By 3.
Regular 3. It's already got the minus sign. You don't need to do the minus. Just do 3. Just take that top equation, say, all right, by positive 3. See how that'll make, was it 24x minus 3y and 60. Make sure you multiply all the way across. You have to go all the way. You can't just do one part of an equation, right? Left side, right side, all the terms, both sides. And then the bottom one, I'll just bring that down. No change to him. See how they're opposites now? See how those, I made the y's opposites, same number, one positive, one negative? Does that make sense? They'll be 0, right? Minus 3y plus 3y. is 0. Is that good? Is that making sense on that? And then this is 24x and 1x, so what is it, 25x, and this is some big number, 75. Good to there so far. See how the y's dropped out? I made them opposites. And now that there's no more y, now we're in business. This is what we like better, huh? We don't want two letters. That's why our goal is to get one to eliminate. This is called the elimination method. It's also called addition because you add them to make them eliminate. You know? So we like having only one letter, much better. So now how do we solve for x? Yeah, just let me divide here. Divide by 25. X is 3. And then bring it up here. Plug in x is 3. Where do we plug in x is 3? Anywhere you want, right? I'll just grab the first one. But the second one might be easier. Doesn't matter. Looks easier, huh? But I'm just going to go with my habit. I'm a creature of habit. 24 minus y is 22. So I plugged into the first equation. Would have been better to plug into the second. That would have been easier. But this will be fine. Oh yeah, the answer is always the same. It's just harder to get there sometimes. But yeah, it's the same exact answer. Math is always the truth. So minus 24 from both sides. Minus y is minus 2. Now what? Yeah, to get rid of everybody good. I hope I'm not rushing ahead of you. So let's see what I got my answer 3. 75 divided by 25 is 3. I bring it up here to plug it in. I grab the top equation, what I always do. Plug in the 3. 3 times 8 is 24. Minus y is 22. Subtract the 24 from both sides. It's gone. Minus y is minus 2. Now you can't leave the minus. You got to get rid of it. How do you get rid of the minus? Divide by minus 1. That gets rid of the minus because 2 minuses is plus, huh? So then y equals plus 2. Am I on the screen there? No. I am off the screen. So y is plus 2. So we got it. What's our answer? X, what was x? 3? And y was 2. There it is. Plus 3 plus 2.
So how would you know to divide by or multiply that 3?
Yeah.
How would you know if it needs to be negative or positive?
Yeah, good question. What I was doing is I was looking right.
Or you can negative 1.
I was looking right, exactly. I was looking right here. Yeah, so what you do is you take aim, so to speak, you focus in on the two y's, okay? Notice one of them has already got a minus, and the other one's already got a plus before I do anything. So I don't need to do any sign stuff. They've already got opposite signs, right? Whereas the last one, let me look back. See on the last one how they were both plus? So I had to make one of them negative, so I had to do the negative. It's a good question. Does everybody see that? So if they've already got 1 plus 1 minus, you don't need to do anything with minus. But if they're both plus, or if they're both minus, you gotta make one of them the opposite. You gotta multiply by negative to make one of them the opposite. Same number, but opposite signs, right? So I had to make them. So this one I just really did the number. He needed to have a 3 put there to make him negative 3, right? That's why I did the 3 to make him negative 3. Good? All right. All right. Number 6. Yeah, try that one. X minus y is minus 9. 7x minus 9y is minus 71. So take aim at those y's. Look at those y's with me for a minute. Do they have opposite signs right now? No, they're both negative. So you're going to have to change one of the signs to positive, and you got to make the numbers the same. Right now, the top y really just has a 1, huh? That's a minus 1y, and the bottom is a minus 9y. So you're going to have to multiply that top equation. What do I need to make? I need to make that top negative 1y become, I need to make it become what? Positive 9y. It's got to be the opposite of the other one. Remember, we're making opposites, right? So you just look down at the bottom one, you go, whatever you are, I gotta make the top one the opposite. So the bottom one's negative 9y, I gotta make that one plus 9y.
So negative 9.
So, right, everybody with me on that step? You've gotta make this one the opposite. You have to change it and make it opposite. What's the opposite of minus 9y? Plus 9y. So you gotta make this plus 9y. How do you make that plus 9y?
Divide by
Negative 9.
-1.
You multiply by negative 9.
That's what I meant.
Multiply through by negative 9, right? Negative 9, because negative 9 times negative 1. Negative 9 times negative 1 will become plus 9, won't it? Plus 9y.
So not a negative 1 then?
No.
No.
The negative part will change the sign, and the 9 will put the 9 in. Right? What times negative 1 will make it positive 9? Negative 9. Negative 9 times negative 1 is positive 9. Does that make sense? So minus 9x plus 9y plus 81. And then I just bring down the second ones. Everybody see what happened there? See how negative 9 times negative 1 made positive 9y? See how they're opposites now? Like that? So make them opposites. And now, add them up, cancel out. We made that happen, didn't we? We forced that to happen because we want y to drop out. Is that good? If this is confusing for you, Roberto's available. He's glad to help. There's his hours. The two students I told you about, they were constantly. The gal that was like 4 years ago, one of my favorite students of all time, that had been on drugs and had a rough past and was on serious pain medications, so she was always a little foggy. She almost never got it in class. She would always come up after class. I am totally confused, Mr. Heron. I'm heading over to the tutors. And yet she got an A in this class and a B in the next. So that's what you need to do. If you're not getting it out of class, you got to go get the help you need. All right, and so this is 10 there. Negative 2x equals 10. We good? 7 minus 9 is negative 2. 10. Right, y dropped out. That's always good news. Now we can solve for x. What do we do to solve for x? Divide by the negative 2, right? Whenever we divide by the identical twin. Same sign, same everything, right? So then that's gonzo. X is, was that negative 5?
Yeah.
X is negative 5. Now we plug in. Plug in x is negative 5. Where do we plug it in?
Either one.
Yeah, either one. Let's grab the top equation. So x minus y is negative 9. Put that in there. Negative 5 minus y is negative 9. Good to there. What do you do to finish solving for y there? Good. Add that 5. That gets rid of that guy, right? And then we have what? Negative y is negative 4. Good. And last step, that we got to get y alone. What do we do to finish getting y alone?
I cut it after.
You got to divide by negative 1. Or just switch both signs if you want. Same thing, huh?
About the negative sign.
Positive 4 there. So what's the answer then? Negative 5 for x, regular 4 for y. We got it. We could check it. We could plug them in, but we don't got time for that. Good on that? Questions I can answer? Yeah.
Minus 7. Then I thought this was the minus sign.
All good?
I thought
Any
it was
questions?
-7,
We good?
Me too.
All right. R's going up. All right. I don't like R and S because my S's look like 5s and stuff. So I'm just going to make it X and Y. It's all the same thing. It's easier for me to write and you to follow, I think, if I do X and Y. Okay. I'm going to do that. Okay. Now we're going to have to mess with both equations. days are over.
You got times 38.
So now we have to mess with both equations, right? Because look at these y's. They both have numbers. We're not going to be able to just multiply by one number to make them the same. So here's what you do. Let me write a note out here that might help. When both y's have numbers in the front. That's what we're talking about here, right? Both the y's have numbers in the front. When both y's have numbers in the front, multiply equations by the opposite, the other number. Does that make any sense? I think once I show you that'll make more sense. In other words, I'm going to look at the top equation. I'm going to have to multiply both equations. Well, you know what? Let me change that wording there. Multiply both equations by opposite number. That's probably a more clear way to say it. So multiply both equations by opposite. So in other words, I'm going to take the top equation and multiply by 7 because that's the other one's y. And I'm going to take the bottom equation and multiply by 8. See how I did a switcheroo thing? See what I mean? You multiply by the other one. So the top equation, I'll take the other y and multiply the other equation. This y and multiply that equation. Does that make sense on that? You multiply by the opposite y. And then that'll make them the same. Why will that make them the same? Because they're both going to be 7 times 8. 56. The sign does matter. And let's make sure we have them. What do we want to happen with the signs? Good question. Let's talk about signs. What do we want to happen with the signs? Do we want both positive 56?
No.
No, that wouldn't cancel. Do we want both negative 56? No, that wouldn't work. What do we want? One positive, one negative. Now, do we already have that, or do we need to fiddle with the signs? From the beginning, we've already had one negative, one positive. So we're not messing with signs. Does that make sense? So the signs are a separate issue from the numbers. You want to see it that way. You got to make the numbers the same, but the signs opposite. One positive, one negative. Right? So there's the number issue, make the numbers the same, and then there's the sign issue, make the signs opposite. Right? The signs already are opposite, aren't they? There's already a negative on one of the y's and a positive on the other y. Does everybody see what I'm talking about there? Right? There's already a negative on one of the y's and a positive on the other y. So I'm not messing with signs. They're already just like I want them. But if they were both plus, or if they were both minus, then you would need to make one of these guys negative. It doesn't matter which one, or this one, whatever. Just make one of them negative because that'll change one of them and then they'll be opposites. Should I say that sentence again?
I'm just looking at it right now, and I feel like once you distribute the 8 and 7, it'll still be a positive.
Right. Yeah, maybe it's best to just do it at this point. I'm probably over-talking it. Let's just go ahead and distribute now. So here we go. Boom, 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 boom. So use your calculator, big numbers. 56y, 73, 105. And then 64x plus 56y is 8, 8, 16, 8, 96. Is that right?
Yeah.
Everybody see what happened there? See how those y's are opposites?
Yeah.
Same number. Why are they the same number? Because we multiplied by the other number, so they both ended up having a 7 times an 8.
Wow.
Yeah.
See how we made them both the same number, and they already did have opposite signs, so we didn't mess with the signs at all. Perfect. Now when we add them, bye-bye y's. Right? See how we made that happen? We designed it so. That good?
This is a really weird equation.
Is it a weird one? It is. Big numbers, huh? 100 and...
The answers end up being the answers.
Oh. So 791, is that right? We could do that? So far, so good? I think I did that right. Tell me if I do a wrong number.
It's good.
Okay.
Oh, you got it right.
Now you got to divide by the 113, right?
You get 7.
Is it 7?
Yeah.
Nice.
And the other one is 8.
X is 7. That was nice. X is 7. Okay, come on up here. Now plug in. X is 7. Where do we plug in?
Either one.
Anywhere you feel like plugging in. Literally anywhere. So I'm just going to grab the easiest thing. What looks easiest? Probably this top one right here before I messed with it, you know. Pretty good to there. And plug in 7. What's that? 49 minus 8y. How do you finish getting y alone there?
Subtract 49.
Yeah. Subtract 49. And so minus 8y is something. Minus 64? Yeah. And then divide by, what do I divide by here at the end? Yeah, the identical twin. Same sign, same everything. Negative 8. So when all is said and done, y is positive 8, isn't it? Positive 8. So the final answer is 7, comma 8, x, comma y. So that's a lot of steps. That makes sense there? Yeah.
Well, didn't I change the answer if you want to change it from like all to?
No, it'll be exactly the same. Plug it in again. But I think it's easier to plug into the ones with smaller numbers before you. Yeah, it'll work in any of them. First one, second one, or the altered first one, or the altered second one. It's all the same. Questions on that one? Are we good? Does that all make sense? All right, let's. All right, let's try this one. I'm gonna make it x and y because my s's look like 5s. So 3x minus 8y is minus 52. 8x plus 3y is 56. All right, so take aim at the y's. What are you going to... Hey, and let's look at the y's. Let's look at their signs first off. Are their signs already opposites?
Yeah.
Yes. We already have one negative 8y and one positive 3y. We already have the signs plus and minus opposite. So they're good, huh? I'm not going to mess with the signs. No messing with signs. They're in good shape. I'm happy about them. But I am going to mess with the numbers. 8 and 3 need to become the same number. One with the negative, one with the positive, so in the end, they're opposites, really. But they got to become the same number. So what do you do when they both have a number in front of them?
I'll
Multiply the equation by the opposite one, right? So I'm going to multiply the top equation by what? 3. Everybody tracking with me? Top equation by 3 and bottom equation by 8. So you always multiply by the opposite, whatever's in front of the other y, the other equation's y. Take it from there. right, how we doing? You getting that? So boom, boom, boom. 9x minus 24y is minus 156. 64x plus 24y is 448.
Yeah.
And then add them up. See how we made those y's be the same exact number, but one negative, one positive, so they're opposites? By multiplying by the opposite y. Is that good? They cancel by design. What's a 73x and
292.
what is it?
292.
292? Thank you. Good to there.
R equals 4.
Oh, nice. Nice, good. 73. It's always nice when you have all these like ugly numbers and they just come out clean, huh? That's when you know you're making it.
This is not like chemistry.
Chemistry comes out ugly, huh?
Oh my god. Ugly numbers, you don't want to do anything with.
Yes. This is how I knew I was going to graduate with a master's degree. I had this certain exam I had to take, and it was really scary. And the numbers started coming out clean. I failed it the first time. I had one more shot, and the numbers were coming out clean in the middle of the test. I'm like, oh, I think I'm going to pass. They're coming out clean. I'm going to graduate. All right. So we got the first one. X is 4. Is that good? Now plug it in to get the other one. Plug in X is 4. And where do we plug in? Anywhere you want. The original 2, the altered 2, whatever. Just grab something and plug it in. I'm just going to grab the first one, like I always do. 3x minus 8y is minus 52. Plug in the 4. 3 times 4 minus 8y is minus 52. That's 12. These are a lot of steps. So then you got to solve. So subtract 12 from both sides. Cancels out. So minus 8y is something minus 64. Hey, that looks familiar. Yeah. Divide by minus 8. And so that is positive 8, huh? Positive 8. All right, so the answer then is 4, 8, x, y. Good? This making some sense?
This is not as brain scrambling as all the factoring and all the eliminating and all.
Yeah. So x equals 5y, and 3x plus 14 is y. I guess I'm kind of moving things around here.
Well, it already tells you what x is for one thing, so that's good.
Yeah. I guess it's not a number though, it's got letters, but yeah. All right, well this time they're kind of rearranging things, aren't they? Right? So now you've seen all the basic ones, now they're going to start playing funny business, they're going to move things around and stuff. So the deal is, as long as they're lined up, it's all good. I'm not going to move anything around because they're lined up. X's are over X's, Y's are over Y's, and then there's numbers. So as long as the X's are over the X's and the Y's are over the Y's, it's good enough. You don't have to move anything around. Now, if they're not lined up, X's over X's, Y's over Y's, then you do have to move them around, and they'll probably give us one of those in a minute. But this one, I don't really care where they are as long as they're lined up. So it's good. All right, so what am I going to do now? Well, you know how we've been getting rid of the Y's all the time? We could have gotten rid of the X's. It doesn't really matter which letter you get rid of. Just get rid of some letter because you don't want 2 of them. You just want 1 of them. That's the thing. So why don't we switch and do X this time? Why don't we get rid of the X's first this time? It doesn't matter. You can do whichever you prefer. So to get rid of the X's, what am I going to do? Well, notice, do both X's have numbers in front of them, or just one of them? Well, yeah, but I mean, other than the 1. You're right. Yeah, only the second one has a number other than 1 in front of it, right? Only this one. It isn't like there's a 3 and a 7 or something. right? If there was a 3 and a 7, we would just multiply by the opposite, right? But there's not. There's not numbers on both. There's only a number on one x, so multiply the other equation by that, right? Isn't that what we always do? We multiply by the opposite thing, right? That's the same thing here, but only the bottom one has an x. So I'm going to multiply the top equation by 3, but not really 3. Yeah, negative. Let me clean this up. It's getting to be a big mess. But yeah, it's going to be negative 3. Do you see why? Let me write it out again and we'll talk about it. Okay, so again, I'm going to multiply the top equation by 3. Why? Because that's the, bless you, because that's the top one. Right? We always do the opposite. But it's got to be a negative 3. Why? Because the signs in front of the x's are the same, and you want to make them opposite. Let me hold up there again. Am I starting to do the Charlie Brown teacher, the wah, 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 wah? Let me come in a little more clear. All right, there's two issues, right? There's signs and there's numbers. Two separate issues. We got to make the numbers the same, the signs opposite, don't we? What are the signs in front of the x's? We're doing x's, not y's this time. What are the signs right now before I do anything new? What are the signs? They're both positive. There's nothing in front of the x or the 3x. There's nothing, which means positive, right? Right now, both of them are positive, aren't they? We don't want that. We want them opposites, don't we? We have to make signs be opposite. So therefore, that's why you've got to multiply one of them by negative to make it become the opposite. Everybody with me on that? That's why when the signs are the same, to start with, you've got to multiply by a negative to make it opposite. And then why am I doing the 3? Why the numbers? That's why the sign. That's why the negative on the negative 3. And why the 3? Well, because you got to multiply by the other x. Right? See how we do that? We always multiply by the opposite one, the number in front of the other x or y, whatever you're doing. We're doing x in this case. You multiply by the number in front of the other x, and if you need to change signs, if they started out same signs, so let me just write it over here. They started at the x's started out both positive, so multiply by negative 3. It turns out. You with me on that? If both x's, or y's, if you're doing y's, if both x's start off with the same sign, you got to multiply by negative to make them opposite, and then you always multiply by the number in front of the other x. So that's what we do. Here we go. What do we got? Minus, well, that's pretty scribbly. We got, I still can't do it. Minus 3x equals minus 15y. The bottom one is unchanged. Add them up. X's cancel. 14 equals, good so far, the x is canceled by design. We made that happen. What happens with the y's? What's negative 15y and regular y?
14y.
That's really a plus 1y, isn't it? So 1 minus 15 is minus 14y. We good? Right? 1 take away 15. Everybody good to there? We see what happened with the two y's there? I just combined like terms. Positive 1 take away 15 is negative 14y. Last step to solve for y. Y said, I won't be alone. Get rid of this thing that's with me. What's with the y? Negative 14. We always divide by identically what is next to y. Same sign, same everything, huh? Whatever you do to one side, no choice. Do the same thing to both. So y equals, what's positive 14 over negative 14? Negative 1. So we got y. Let's come back over here. And now we plug in to get the other one. Bring it over here. Plug in. Y is negative 1. So which equation do we grab? I'll just grab the first one. It doesn't really matter. That actually will be the easiest one. X equals 5y. Plug in the negative 1. X equals 5 times negative 1. X equals negative 5. We got it. So our answer is -5, comma, -1, x, comma, y. We got it. We good? Questions on that? So again, I did x's this time instead of y's. It doesn't matter. You could have done y's. You always multiply by the number in front of the other x, and if they're same signs, you multiply by negative to change its signs. And that makes them opposites, and that makes them cancel. Any other questions? We good? All right. Let's see. All right, so there we go. So 2x minus 3y is 33. 3x plus 6y is -3. So what do you guys want to do on this one? X's or y's? You know what would be easy? Probably the easiest thing to do on this one would be the y's. See how that y, what can I multiply -3 by to make it the opposite of plus 6y?
2.
Just multiply it by 2, right? Now I know normally I give you the rule, multiply once, but really, in the end, it's the easiest thing to do is whatever will make the two y's or x's opposites. Right? That's the name of the game. Make them opposites. Does that make sense? So I'm looking right here and right here, and I'm saying I need to make one of those negative, one of those positive. They already are. So I don't need to mess with signs, do I? They already are one negative, one positive. So that's good. I just need to make them the same number. Don't I? Just make them the same number, and then they'll be opposites. So what do you got to multiply that 3 by to make it the same as the 6 down below it? 2. Yeah, so that would be easier. That way you won't have to mess with both equations. If you did the x's, you could do the x's, it would work, but you would have to multiply both equations, wouldn't you? Because the x's both have numbers in front, you'd have to, that'd be a little more work. So just multiply the top by 2. Everybody see that? See how I'm thinking about that? Boom, boom, boom. Like that. X minus 6y is 66. That good to there? And then the bottom equation. Add them up. Bye-bye y's. Everybody see what happened there? It's getting more comfortable?
Yes.
Like an old shoe?
Clean numbers, I like this.
Yeah, this is a little nicer, huh? Not the hundreds and stuff. 7x is 63. Yeah. Divide by 7. X is 9. Bring it over. Plug in. X is 9. Good, am I racing ahead? We good there? So then you grab the first equations, what I always do anyway. 2x minus 3, y is 33. Plug in the 9. What's that? 18 minus 3y is 33. Like that, right? Y is saying I want to be alone. Subtract 18. So minus 3y is something, 12, 15. Last step, divide by minus 3. And I'm running out of room. Probably I'm off the board here. Minus 5? Yeah, I'm off the board. So y is minus 5. Oh, I'm still off the board. So put it up there. So y is minus 5. Did you get that okay? So then the answer is 9 comma minus 5 x comma y. We good? Questions I can answer? All right. Okay, so here we go. So P equals 46 plus Q. They're using P and Q now. 8P is minus 2Q plus 398. All right. Notice things aren't lined up, right? They mixed up the order of things. So first thing is to get them lined up, you know? So I would just rearrange those top two, these two. It doesn't mean you can move whoever you want. I'm just going to swap these two, put the Q there and the 46 there. Now it's good, right? P's over P's, Q's over Q's, numbers over numbers. Does that make sense what I did? Why didn't the sign change? When do we move things and the sign in front changes? When does that happen? When you move to the other side of the equal sign. I didn't jump over the equal sign, did I? Right? That 46 and Q stayed on the right side of the P. They didn't jump over the equal sign, right? It's only when the cow jumps over the moon, when you jump over the equal sign, that you change signs, right? I didn't jump over the equal sign, right? P and Q, I'm sorry, 46 and Q, just switched with each other, but nobody jumped to the other side of the equal sign, did they? Does that make sense? They're right where they've always been, on the right side of the equal sign. So nobody's sign changed for that reason. Okay. All right. Can you take it from there? I feel like I've been coaching you through these. Let me see. Let me let you do this. And why don't you do the Q's? I'm going to do the Q's. Why the Q's? Because they're already opposite signs. See how the Q's are begging me to do them? They're saying, do me. The Q's are easy. The Q's are ready to go. Because one of them is a positive Q and one of them is a negative Q. They've already got opposite signs, huh? Whereas if the P's, I'd have to do more work. The Q's are ready to go. Do the Q's. When I say do the Q's, what do I mean? Make them opposites. Make them the same number, one positive, one negative. If they've already got the positive, negative, just make them the same number. And then they'll drop out. So what am I going to multiply the top equation by?
By 2.
Positive 2. Positive, boom, boom, boom. Good on that? See how that'll make positive 2Q, which is the opposite of negative 2Q? Was that 92? And the bottom equation, I just bring it down, no change. Good to there. And then the Q's cancel, and you get 10P. And this is some 490. Right? Because I just added that little 2 to 398, made 400, and then the 90. Anyway, you can just calculate it. All right, so what do we do now to get P alone?
Divide by 10.
Divide by that 10, we good? Divide by the 10, so P is 49. I can divide by 10, just cut off a 0, huh? P is 49. Who needs a calculator on this one? P is 49. Now, plug that in. Plug in P is 49. Where do we plug it in? Anywhere we want. I just grab the first equation all the time. So that's P equals 46 plus Q. Plug in the 49. 49 is 46 plus Q. Last step, divide by subtract 46. And we get Q is 3, right? So we've got it. P and Q. Put them alphabetical. P before Q, like P comes before Q in the alphabet. 49, 3. P before Q. LMNOPQ, right? The alphabet. We good there? Okay, if I move on. Questions on that one? He's getting easier, seeming better?
No, because you're gonna throw a fraction at us right now.
Yeah, I know, it's true. Yeah, right. Yeah. Something really strange. Not hard, just weird. Will happen.
So there's no solution.
We will see. Yeah, that's correct.
Just guess. Guess B and C, and it does not make you know it has to be A.
All right, so anyway, just pretend you don't know anything. There will be one of these on the exam, and I'll explain how people get tricked by it. Do the X's or the Y's, whatever you want. Pick your favorite. And when I say do the X's or the Y's, what do I mean do them? What do you do to them? Make them opposites, right? Tracking with me? Either hone in on the, why don't we just do the X's? Just hone in on the X's. Look at those X's and say, I'm going to make you boys opposites, right?
Okay.
Make those X's opposites.
You can't do it.
You've already got opposite signs. The signs are already ready to go. The 5 is plus,
Everything equals
the
0.
10 is minus. So you just have to make them the same number. Question? Oh, did I miss that? Oh, yeah, thank you. Yeah, so I got to make those X's opposites. Oh, then it's not no solution. It's infinite solutions.
Oh, it's
Yeah, so that's the key. You got to know which of those it is. That people get tricked on the test. All right, you ready? So we're going to make the X's opposite. So take the top one and multiply by 2, right?
Yeah.
I don't need any minuses because they already are opposite signs. Positive on the 5, negative on the 10. They're already opposite signs. 10x minus 8y is 6. The bottom equation, no change. So I'm going to add them up now. I made the x's opposite, so that's 0. I made that happen, and lo and behold, so did the y's. I didn't even try to make the y's cancel. They canceled, and so did the other numbers. 0 plus 0 equals 0. That means infinite solutions. The answer is B. Now, the other kind of answer you can get is 0 plus 0 equals a number, that's not 0. Like 7 or something, 0 plus 0 equals 7. That's no solution.
because 0 is not equal to 7.
Right, exactly. No truth, no solution. That's how I remember. Yeah, if you get something like 0 plus 0 equals 7 or something, that's not true. Whereas this one is true, right? 0 plus 0 does equal 0. I mean, it's a simple truth, but it's true. So we would expect answers. In fact, there's infinite answers. Whereas this one is not true. No truth, no solution. You have to keep those straight. A lot of people miss those. I always put one of these on the exam. No surprises with me. No surprises, right? One of the questions on the exam is always like this, and you want to keep straight whether it's infinite or no solution on that. So no truth, no solution, but this one's infinite. 0, 0, 0.
Does equal 0.
Because 0 does equal 0. Let me see. What should we do? If they bug you, you can get rid of them. Maybe you should. Yeah, just move them all 2 places. You can move them all the same amount of places. Because that's multiplying by 100, really, right? It moves in 2 places. So I would just move this 2 places. 2x, move it 2 places. 14y, move it 2 places, minus 68. Is that good? I just moved it 2, because that's really multiplying by 100, 100, 100. You don't have to write the 100. Just move the decimal, you're fine. Right? That's why that's okay, though. I just multiplied through the top equation by 100. Moved all the decimals 2 places. Take the bottom equation, do the same thing. Excuse me. Actually, the bottom equation, we just need to move 1 place, huh? Yeah, just multiply the bottom equation by 10. Just move them all 1 place. 3x, 4y, 23. Everybody see what I did there? So the top, I moved the top, moved 2 decimals, well, 2 decimal places, and this I moved 1 decimal place. Good? All right, take it from there. Can you solve it from there? Would it be easier to do x's or y's?
The y-axis.
It's not a big deal. Maybe the y's a little bit because they already have the plus and the minus. What you want to do maybe you'd prefer the x. Let's do the x's. Probably because those are smaller numbers. So anyway, I'm going to do the x's. You guys want to do the x's? Let's make the x's opposites. We'll do the x's opposites. You can do the y's if you really want to. I'm going to do the x's. Pretty close. Pretty even. Which one will be easier? So I'm going to make the x's opposites. Now look at those x's. What are their signs right now? Are they the same signs or opposite signs right now? They're both positive, aren't they? So you've got to make one of them negative, don't you? You got to make one of them negative. When you multiply, you've got to make one of them negative. Doesn't matter which one. Just make one of them negative so they'll be opposites. And what numbers do you multiply by? You're doing the y's, so you're doing something else. So you multiply by the 3 and the 2, right? You multiply by the 1 in front of the opposite x. The number in front of the opposite x. Right? So this one I'm going to do -3. This one positive 2. Everybody see what I'm doing? I'm switching up. Right? Everybody tracking? Everybody see that? And I made one of them negative. You could have made the 2 on the bottom negative. That's fine. Just don't make them both negative. Make one of those negative, either the 3 or the 2. Because you got to make one of these x's negative, one positive. Right now they're both positive. So you got to multiply one of them by a negative. It doesn't matter which one. But don't do both. Right? Everybody seeing that? Everybody smelling what I'm stepping in? That's what they say in the South. If you're tracking those, I love that saying. It's a great one. It's a good picture. Are you following close behind? So multiply through like that. So you get minus 6x minus 42 plus 192. Is that good? Yeah. Minus 3 times 2.
What you get?
Bottom negative?
Wait, sure.
Oh, never mind.
Oh,
Good try.
Yeah.
oh.
Shit.
Wow. I was in, because your answer made more sense. How'd you get that 204? Or did you subtract both of them?
Doing badly in my head today. Yes.
Subtract them.
Was it 204? Thank you.
It is 204. See, you got
Sorry, I did the math wrong. I do that sometimes.
You get it right.
Good to there? See how, and now look at that, we're going to add them up, and the x's are going to go bye-bye. We made the x's opposites, right? So what do the y's become? Negative 50y, and this is 250. Is that right? Negative 50y is 250.
You get negative 1.
Everybody good there? Divide by the identical twin, exactly what's next to the y, negative 50, same sign, same everything. So y is negative 5, isn't it? We got y. I'm going to go dot, dot, dot. I got to get to some other things. Then you plug in, get x, right? Plug in, y is minus 5, get your x. The rest is the same. Good to there? Questions on that one? So if you got decimals, move them. Make them whole numbers.
I hope I remember this when I go back to this and continue. Dot, to be continued.
That's right. Like a cliffhanger. All right. We good? Can I flash on from that? Okay, so here we go. That's the plan, exactly. Because we don't like fractions. Okay, yeah, so the deal is, when you have fractions, let me write it up top. This is the only fraction problem. Fractions multiply by the LCD every term. All right, so I got to find the LCD. So if I put the 2, the 4, and the 3 in the LCD box, see what I'm doing? 2, 4, 3. You guys with me? I grab the 2, the 4, and the 3, and I put them in the LCD box. Remember how to do that? So then you what goes into a couple of those?
2.
2 does. 2 goes into 2 one time, 2 goes into 4 2 times. Bring down the 3 because it doesn't go in. Good to there?
12.
And then multiply them together. 2 times 1 times 2 times 3 times 12. 12. So I'm going to go 12, 12, 12. I'll do the bottom one in a minute. Let's do that top. Let's finish that top one first. 12, 12, 12. Everybody good to there? The common denominator for 2, 4, and 3 is 12. I found it by the LCD box, the L box. So now, remember how it works when you multiply? You cross cancel and multiply what's left over. So 2 goes into 12 6 times, 6x. This will get rid of all of our fractions, and we won't have any more fractions. 4 goes into 12 3 times, and it's 3y. Good so far? And 3 goes into 12 4 times 2 times 4 is 8. Did we all track with that top equation? I'm done with the top one. Much nicer, right? No more fractions on the top one. See what happens? See how you canceled out? What's left over multiplied? Now let's do the LCD for the bottom one. Let's go over here. Can you do the 3, 5, 5? So 3, 5, 5. Want to find the LCD for 3, 5, and 5. It's going to be 15. Yeah, go ahead. You want to do the formalities? If you just know it's 15, great. You don't have to mess around the box. If you're not sure, do the formalities. 5 goes into a couple of those numbers, goes into the 2 5s. 1 time. Doesn't go into the 3, so just bring it down. Remember that? And then that's it. Nothing but 1 goes in. So multiply equals 15, huh? 15 is the LCD. All right, so I'm going to do the 15. What am I going to do? I'm going to multiply by 15 in the left, 15 in the middle, 15 in the right. 15 for every term in the second equation. This is what we always do with fractions, huh? We just get them out of there. Have you noticed this is pretty much always our game plan with fractions? Get them out of there. Multiply through by the LCD. Take them out, right? That's what we do with fractions. So 3 goes into 15. 5 times. Multiply 5 times 2. 10x. Good so far. See how the leftovers multiply? Cross cancel. Leftovers multiply. Minus. Now for the middle. 5 into 15. 3 times. 3 times 3?
Negative 3.
9y. Yeah, I've already got the negative sign down there. Negative 9y. Last one, 5 into 15. 3 times 3 times 1, 3. Much nicer now, huh?
But
No more fractions, right? See how we got rid of the fractions? Now you just do what you normally do starting at this point. What do you normally do? Dot. I'm going to go dot, dot, dot. Yeah, top one. Yeah, the next step would be to make opposites. Who would you make opposites? Yeah, maybe I will do one more step. Is everybody good? So just pretend the problem starts off right here. Once you've got rid of those fractions, just forget that you ever had them, right? And just pretend this is the original problem. From this point forward, I'm never going back to those fractions. I'm just going to look right here and work on this.
It gives me a really weird, 28x equals 27.
Oh, is it? Okay. All right. I better do it then. All right. Thanks. All right. So here we go. So we're going to make opposites. So the easiest one would be the y's, huh? See how easy it would be to make those y's opposites? Just multiply that top equation by 3. He'll be a plus 9y, the opposite of minus 9y. Does everybody see that?
18x plus 9y equals 24, 10x minus 9y equals...
Hold on. That doesn't help. I don't need all that information right now. Makes sense? I'm just focused on the y right now. I just want to make those y's opposites, right? Everybody see where I'm looking? I'm looking right here saying I got to make that the opposite of minus 9y. I got to make it plus 9y, right? So multiply through by 3. Everybody see that? See how I'm determining that? It's all about opposites, isn't it? Boom, boom, boom. Then I get 18x plus 9y is 24. The bottom one, I'll just bring it down. 10x minus 9y. 3. Add them up. These cancel. I'm going to have to bring it kind of out of room here. Over to here. Over to here, here we go. Yeah, so bringing it up here, yeah, I'm going to get, what, 28x equals 27. And then divide by 28. There's the answer for x. That's awful. 27/28. I don't want to plug that in. Right? Normally we plug in now. This is a really hard one. Just go C. No, it's not C. That'd be your first strike. It'll say no. Strike 1. No, it won't take decimal. See what they said here? No, I'll show you. You know what? There's only one of these in the homework. I'm not going to put one this messy on the test. I'm running out of time. So what I'm saying is I'll do it, but I'm going to do it quick. So, all right. So here's what you do. This is now Math 103, the next course. We do these more thoroughly. I put one on the test, or me, and I'm sure whoever else teaches it. You know, that's we just kind of crank it up a level. But this class, I'm not going to put one of these ugly fraction ones on the test. There's only one in the homework. Here's what you do. When the first answer is a fraction like that, you don't want to plug that in, right? Instead of plugging in, because that's so ugly, restart. Now, I don't mean restart all the way back. I'm never going back to these fractions. But restart to here. Just restart to there. 6x plus 3y is 8. 10x minus 9y is 3. And make the other letter cancel. Make the other letter cancel. Again, I don't have time to explain this in detail. I mean, I got to get on to other things. Last time, see how I made the y's cancel last time? I made the y's opposites, so they went away, and thus I got x. Well, this time I'm going to make the x's cancel instead of the y's. So multiply by opposite. So I'll go negative 10 on that one, positive 6 on that one. Boom, boom, boom. Negative 60x minus 30y minus 80. The bottom is 60x minus 54y is 18. Add them up. Bye-bye x's. Minus 84. It's kind of going too fast. Minus 84y, if you can read my writing there. And that's minus, what is that, 62? Divide by minus 84. There's y. And it's ugly. It's two negatives. It's positive. And then you got to reduce it. So y, this problem never ends. 62 over 84. The two negatives cancel. Reduce it. What's that? Tired of that problem. Come see me if you want help on that. It'll be on the YouTube. Okay. So here we are in 7.2. X plus y is 6. Y equals x minus 4. All right, so on this one, basically what I'm going to suggest in this section, they're calling for a different method. And that's fine. I'll show you one of those. But I never care on the test what method you do on anything. So I'm going to suggest, the reason I did these out of order, and I did 7.3 first, and I went real slow and covered almost every problem, and I'm just going to flip by this one quick, is because I'm going to suggest you just do the same thing. Just do the same thing we did in the last section. It's the best method. That's why I jumped there first. The elimination method that we just practiced for a long time, that's the best method. So my suggestion in general is going to be just always do the addition method. No matter what method they ask, MathExcel's not going to know what you did. You just type in the final answer. So let's just do the addition method. Now, if I want to do the addition, so I'm just going to do the addition method. If I'm just going to do the addition method, that means first line things up. Remember how you got to get x's over x's and y's over y's and numbers over numbers? Really, the best way would be x and y on the left side, then the equals and the number on the right side. Yeah. Let's line them up like that. Let's get the x's and y's on the left side and the numbers on the right side. So this one's already in good shape. He's like, I'm good. I got my x's and my y's on the left side, my numbers on the right. He's good, but the second one's out of order. So what am I going to do on that second one? Grab that x, and the cow jumps over the moon, right? When it jumps over the equal sign, what happens? The sign changes. So I'm going to rewrite the top equation, no change at all. But the second equation, now it's going to become negative x plus y is negative 4. Does everybody see what happened there? When that x jumped to the other side of the equal sign, the cow jumped over the moon and changed to negative x. Now they're lined up, right? X over x, y over y, numbers over numbers. So now just do what we learned to do in the last section. Which is what? Make opposites and then add them. Huh. Is anybody already opposites naturally? Yeah, the x's are already opposites, aren't they? Everybody see that? See how the x's are already opposites? So they're ready to go right now. The x's are opposites,
Cancel.
ready to go. So just add them up. I don't need to multiply any equations on this one. Does everybody see that?
We just jumped the x and it turned negative.
Yeah, right. That's not news to you, right? Whenever something jumps to the other side of the equal sign, it changes signs, right? That's what we've been doing for a while, right? Whenever something goes to the other side, it changes signs. That's exactly right. And now we add them up and boom, those x's cancel. And y makes 2y. Right? And 6 minus 4 is 2.
Divide by 2.
We good there? We all good to there? The x's cancel, the y and y makes 2y. And so how do we solve for y? Divide by 2. Y is 1. That good? We got y. Now plug in. Y is 1. Where do we plug in? Anywhere you want, right? I'll just grab the top equations, what I usually do. X plus y is 6. Put in the 1. X plus 1 is 6. Subtract 1. X is 5. So the answer is 5 comma 1. We basically did what we did in the last section. You know? So that's why I covered them out of order and why I did the last section first. So that you could just keep doing that method all the time. Does that make sense? It was a little different, though. We had to rearrange on the first step.
So are you even going to teach us the substitution method?
I will. I'll mention it. I'll do it once.
Okay.
And then I'll...
I think I already know how to do it because I came up with the same method.
So is everybody okay with the rearrangement stuff? Does that make sense? When that x jumped over, became a negative x. That's what always happens, right? When something jumps to the other side of the equal sign, it becomes negative, or switches signs. So yeah, let me redo it now. So we got the answer. That's the answer. And if you want to just do it that way, great. I would suggest you just always do the addition method. Just do what we've already learned to do. You don't have to learn anything new, which you probably would prefer not to learn something new, I'm assuming. And that'd be great. That'll be fine. But yeah, in case you want to see the new method, I will show it. I'm going to go back and redo the same problem again with the new method. Now, little warning. The new method will look better because they've particularly made a very nice problem for the new method.
For the very first one.
Yeah, for the very first one, exactly. About 3 problems down the line, this new method. So don't. When I do it, you're going to go, "Oh, that's easy. I'm just going to do the new method." It's easy on this one. But if you tried it on about 3 problems down the line, fractions everywhere. And you don't want that, right? So really, the one I showed you is the best way to go, 90% of the time. The elimination method that we just spent an hour and a half doing is the best way to go on 90% of the problems. That's why I showed you that one slowly, carefully, thoroughly, and first. Now, having said that, watch. You probably can sense it already. See how that bottom equation says y equals x minus 4? Right? And the top one is x plus y is 6. See how that bottom one says y is x minus 4? That means y is the same as x minus 4. That's what that bottom equation is saying, huh? Y is equal to, is the same as x minus 4. That means wherever you see y, you're allowed to replace it with x minus 4 because it is x minus 4. Make sense? So I'm going to substitute. Like a substitute teacher takes the place of the regular teacher. I'm going to substitute. I'm going to take this and plug it into the other equation in the y slot. Why the y slot? Because y is x minus 4. So the other equation, this equation will become x plus y equals 6. But instead of the y, what am I going to put in the y slot? X minus 4. Because y, which was right here, is x minus 4. Does that make sense? That's what substitution method is. You plug one into the other. Now, why is that so great? Because now I've only got one letter. I've only got x. So how do you solve this? What's x plus x? 2x. How do you finish getting x alone? Add the 4. 2x is 10. Divide by 2. X is 5. Just like we got a minute ago. And now you finish up the same way. Now you plug in. You finish both methods the same. Just plug in x is 5. Where? Anywhere you want. Grab the first equation. X plus y is 6. Plug in the 5. 5 plus y is 6. Subtract 5. Y is 1. 5. Is that what we got? 5, 1? 5, 1. So that's the other method. It only works nicely when they've already got one of the letters alone. That's the deal. If they've already got one letter alone, this method is really slick and nice. But in general, it's a harder method because they don't have one letter alone. So you can just never do that method if you want. Everybody understand what I'm saying? You can just do the first thing I showed you all the time. It'll always work. So let's try number 4. X is minus 5y. X plus 2y is minus 6. So you can do it whichever way you want. They need to be lined up, don't they? So if you're going to do it the way we did it the first hour and a half, then you got to jump this guy over, don't you? To make it x plus 5y is 0. Does that make sense? Everybody see what happened there? I just thought that minus 5y jumped to this side, became a plus 5y. Good. Question? Yeah, right? Was that good? Right? We've done that before, right? Have we? Okay. Yeah, so when something jumps to the other side of the equal sign, it changes signs, right? So maybe that question's been asked twice now, so maybe I shouldn't be rushing over that point. Is that familiar to you? Right? When something jumps to the other side of the equal sign, it changes signs. Switches the signs in front. So that minus 5y jumps around. I thought we'd done that before, I can't remember. I know we've done a lot of things, haven't we? It's 2 months of me talking at you for 5 hours a week or so. Good to there? Like that? Now, is anybody already opposites?
No.
Right, no is the correct answer. So we got to make like these x's opposites, or you could do the y's. X's would be easier. They're the same already. Just make one of them negative, huh? Do you know what I mean? You can just multiply through the top equation by -1, or the bottom. It doesn't matter. Just make one of these x's become negative. They already have understood 1s. They're already the same number, aren't they? They just need to have opposite signs, right? They're already both 1x, aren't they? You just got to make one of them negative 1x. So can you multiply through one of those guys by -1? Is that making sense what I'm saying there? We always have to make opposites. So to make the x's opposites, I'll just take the top equation. You could do the bottom, it doesn't matter. And multiply through by -1. Then we get -1x minus 5y. What's -1 times 0? What's anything times 0? 0. And the bottom equation doesn't change. Is that good? Everybody see how I made those x's opposites now? By multiplying that top equation by -1. Now the x's cancel by design. What's that? Minus 3y minus 6. Bring it up here. Minus 3y is minus 6. We good? See how I made the x's cancel? Divide by minus 3. It's positive 2 for y. Now plug it in. Plug it in where? Anywhere you want. I usually grab the first equation. X equals minus 5y. Plug in the 2. Minus 10. So final answer, minus 10 for x, 2 for y. And I just did the old method. I didn't do the new substitution. You could have done it, so that one would have been easy to substitute.
Yeah.
Because there's already giving you one letter alone. But a few problems down the line, they won't do that. They're fooling you. They're saying, see how nice our new method is?
No, it's not.
And then it won't be. They'll do a bait and switch on you. All right. So we didn't finish, what is it, 7-2. We only finished 7-1.
But it's spring break, so we should do it anyway.
Well, I think we'll need a refresher after spring break. 7-3. We finished 7-3. We went backwards. I forgot. So 7.3 is due, when does it due? Monday after the break. You might not want to wait till a week from now when you don't really remember what we did. Yeah, so that's right. I'm not going to see you guys for what are you going to do without your math fix?
I'm gonna come over and I'm gonna bring my grade up on all my work.
That's a good idea. And if there's some like Tuesday night, Wednesday night, and you're thinking everybody's having fun on spring break in Florida, I couldn't afford to go there, me either, or really want to go there. But you can always watch the old YouTube lectures. They're available, right? All right, click A for Apple. And get 2 free clickers today. I'm just giving away. Oh, all the quiz grades are online. I don't know if you noticed that. If you go on Math Excel, I loaded in all your quiz grades. They're all up to date. So click on your overall score. It shows all the quizzes and the homework and the tests. All factored in. They're all in there. Click A for Apple. Have a good break. I'll see you in a week and a half, I guess. See ya.